AI actually improves productivity, but we have built an entire generation of technology leaders who focus on cost. I think relative productivity is the most relevant even more now that we are talking about AI-enabled coder productivity. But the real new market that's opening up, which is not the first or the second, is the one in the middle. It's translating tech debt into new code. For all the talk about AI transforming our world, in the commercial world, I still see hesitant mini steps of POCs.
What you're saying is the complexity of the organizational behavior and change seems to be a much larger barrier than adopting code generation in the
Technology is easy. People are the challenge.
Hi everyone, welcome to another episode of Zinnov Podcast, Business Resilience Series. I have with me Dr. Ranjit Tinaikar, CEO of Ness, an interesting digital engineering firm which is taking a leading position in the AI-led software engineering area. And we are going to be talking about some very interesting topic. In the age of AI-led code development, one of the concerns for companies is how to measure software productivity. We are going to go into a history of software engineering productivity, and what are some of the latest trends, and how could companies adopt some of the modern practices in measuring AI-led product engineering. Ranjit, welcome to the podcast.
My pleasure. Thank you.
Ranjit, you have an interesting career arc. You started as a professor, then we went into a management consulting firm, worked in McKinsey for a decade. Then you took several operating roles, and now CEO of an interesting AI-led digital engineering firm. Your career is very unique compared to other CEOs I come across in tech services. Tell us a little bit about your career decisions as you went through this.
First of all, it's a pleasure to be on this. We've been talking about this for many months, and finally we did it. So thank you for having me. My career, there are two versions of the story. One is the one I give to my children, which sounds like I have really thought it strategically and planned it. But the real story is that life happens while you're busy making other plans. So if you go through my experiences, actually, even before I was a professor, my first profession was theater. So I wanted to be an actor. I dropped out of school. That was my one thing. Then I was a computer engineer. And then my research was in social networks. And then I worked as a consultant. And then I worked as an operator in a couple of fintech companies. And now I'm a CEO. So you'd say, well, this is all sort of disconnected. But there are two or three themes across all of these, right? I have always been fascinated by technology and its potential. But I'm more interested in how people interact with technology. And so I was a computer engineer. And I used to write code, but actually I did enjoy that as much as how technology can drive innovation in organizations. And so my PhD was really using social networks to look at innovation diffusion, right? So that just gives you a sense of, I like technology, but not for itself, but as a means to a broader end.
How it creates impact.
Yes, right? The second theme is, if you look at it, acting, research, consulting, and now leader of some organizations, there's one common theme across all of them: storytelling. I really think when you're talking about AI or the impact of any technology, it's not the technology. It's actually how people engage with it and what stories they believe about it. So I'm sure you're going to ask me later on, well, does AI increase productivity by 15 to 20% or 55 to 100%? It's a story, okay? And you have to be able to articulate the story to create value for where you are, but also at the same time give value to others. And that storytelling is often not fully appreciated. It's something I've always been fascinated with. How do you tell stories? And that's the second. And the third theme is actually, I do think that you have to recognize that at times, what are the limits of your abilities? And every time I've made shifts in my career, I've reached the limits of my ability. So now that you see me as a CEO, I probably reached the highest limit of my ability. But thanks for asking that question. I wish I could give you a more sort of structured answer, but that's how I think.
But there are commonalities across each of this that you've been able to leverage, or you build those muscles as you went across the career.
Yes.
So coming into software measurement, you have all of these hyperscalers have very interesting code generation software tools, and they go out and they sell the software. They tell the CEOs, hey, you're going to get 100% improvement in productivity. You don't need that many engineers anymore. But when the CEOs go and talk to their team, they hear a very different story, right? The numbers are very, very different. 10%, 5%, 15%. There's no real measurement. They're like, oh, it may be 5%, 10%, right? So before we dive into this in a little bit detail, tell us a little bit about history of how software measurement came in. All of us read this mythical Man-Month book, and you're a student of software measurements and engineering.
Sure. I think it's a great question. A lot of that history is often, when I tell people, they're like, what? But actually, the first attempt at trying to measure or actually control, not even measure, control and improve software engineering, because we couldn't even measure software engineering in the 60s, really, was by the defense contractors who were serving defense agencies. Now, you're building software for all these mission-critical platforms, and you're giving out contracts to all these companies, asking them to build software. They wanted to ensure a certain level of quality and predictability to their deliverables. You couldn't measure software engineering in those days, so what they did was came up with process methods. They said, if you do it in a certain way and you make the process reliable and predictable, then the output is more reliable. And that's the genesis of the capability maturity model, which we take for granted today. It was actually Carnegie Mellon University, where I was a faculty, was part of that process of building the CMM. Software Engineering Institute was part of, and I had the privilege of being associated with that. So I think the capability maturity model was the first real attempt in the 60s with defense contractors to NASA or to defense companies, where it became sort of a national requirement to give you good quality software. Of course, then it was adopted by large corporations. It became standard. By the 70s, 80s, it was going across. And then what happened? The technology changed. It was no longer COBOL and all that stuff. You started seeing object-oriented programming. You started visual programming. You have Visual Basic, remember?
Yeah.
We started talking about business intelligence software. Technology and the solutions you started working on themselves changed. So this traditional CMM, which is based on a sort of SDLC, as they called it in those days, software development lifecycle, where every step in that SDLC was made repeatable, that became less relevant for these new technologies and new applications. So that's where you started seeing words like agile and those kinds of methods. And by the way, I think both the SDLC and agile are great process solutions, but for different problems. They are not, one is better than the other. And then agile led to extreme programming and scrums and all of that. But it was fundamentally a process solution to the productivity problem. Parallelly, as we started looking at more and more process solutions, people started saying, well, why can't we automate that? And so you started seeing automation solutions like test automation or things like that. But the automation was generally limited to testing and some of those very basic steps. Or document.
Or managing releases.
Release management software, those kinds of things. Not the core of coding, which was still considered an art form. So I still remember going to school where we used to have 3-hour debates on, is software engineering an art or a science? And that's the time from which this whole mythical Man-Month came, which is, if you just throw more bodies at a problem, it doesn't solve the problem, right? And so people started getting a little bit more scientific about it. And that's for the first time people started saying, well, let's use lines of code or function points and things like that to measure software engineering. They had limited success, but I'll give you my view after having been in this profession for a long time. Process, automation, and metrics are all important. Don't think they are not important. But software engineering is different from manufacturing in the sense that when you produce a car, you produce the same car again and again and again and again. The way you measure productivity there is very different when you do software engineering. You're producing a piece of software for the first time and the only time. You see what I mean? You're not going to produce the same piece of software again and again and again. So the way you measure productivity is different. I personally don't think absolute measures of productivity are relevant in software engineering. I think. There'll be others out there who will disagree with me. So what we've done at Ness is actually develop metrics, which are, of course, learning from all these process and automation paradigms that we've developed over time, but also incorporate the new DevOps environments and the new cloud-built engineering environment and say, listen, there's a set of metrics. I can measure 100,000 metrics, but let's focus on the two metrics of productivity that are really important. It's not cost. People often use cost and productivity synonymously.
Sure.
Productivity is input upon output, right? Or output upon input. So cost is just the input. Productivity we measure in terms of speed. Can you do more work with the same amount of people, right? Or less work with even lesser people, right?
Sure.
But that's the thing. Second is quality, because quality drives productivity. If you do bad work, you have to redo it again and things. Speed and quality is what we measure, and then a whole set of metrics behind it. I think relative productivity is the most relevant, even more now that we are talking about AI-enabled coder productivity, because the environments are so complex, there are so many variables involved, that there is no absolute measure of what should be Ranjit's productivity if he works in this place. Because there are lots of tools, coding environments, architectures, domains, and they require different relative metrics.
So it's interesting you talked about relative metrics, and one of the things we hear from our customers, it's the types of project matters in how they use AI code development, right? For example, if you're doing a code migration project, it could be 2 times faster. Versus if you're building something new, it requires creativity and a lot more brainstorming among engineers and so on. Maybe the productivity is not so high.
Yes.
Or the type of engineers they have, and you have teams across the globe. How do you bring these dimensions? I know that's related, but are there archetypes of projects where you see this impact higher, lower?
I think it's a great question. Actually, thank you for asking me, but you know the answer to this because you and I worked on this research together about a year ago. Well, you should chime in on your views too. I do think, to your point, the type of task, the type of level of experience of a software engineer, and the architectural complexity are 3 big drivers of how anything affects productivity, including artificial intelligence. So you and I did this research where we found that if it's a existing code, the productivity impact of AI on it is much higher than if it's a new piece of code. Similarly, more repeatable jobs like testing see higher impact than requirements definition, right? Or if it's a more senior person working on a piece of code, the productivity impact of AI is much higher than if it's a junior person. So we do see that the impact does vary by environment, task, and individual. And that is why, again, relative is a better way to measure it, because what in relative it means is that if you were having a completion rate on a release cycle of 85%, then you need to be 86 and 87 and 88 for that same team, for same architecture, same problem, right? That's a more practical way that CEOs and CTOs should look at it.
Yeah.
I don't think absolute metrics will help.
Got it. So one of the other dimensions when we talk to clients, right? Nobody is reducing the tech spend. So one thing you say, hey, I'm 15%, 20% improvement in productivity, whatever the number is. Seems like the work is expanding to capture that additional value, to capture more value. So one of the ways companies spend money is in taking care of tech debt. And we have talked about tech debt. Right now, because you could build the software much faster, companies seem to be rewriting the software rather than maintaining code. So how do you see in a product like, you understand product development lifecycle really well. So do companies now just completely refactor and rewrite software compared to maintaining software? Like how do you see this pattern changing?
I think AI is really transforming that. The need to get out of legacy debt, tech debt, has been around since you and I joined the industry. Every year the CIO says I have to, but we haven't done it. Why? For 2 reasons. One is operational risk. A lot of the mission critical systems are sitting on COBOL platforms, which were written by this gentleman or lady who's now 80 years old. Okay, it runs the core banking or manufacturing system that the organization, which CIO is going to say, I'm going to rewrite this, right? And take a massive career risk and an operational risk. So you typically kick the can and try to layer stuff on top of it to make it look pretty, but it's inside of it, it's still that COBOL core. And that's probably the primary reason, but it is a problem that needs to be solved. Now, what AI has done is reduce those operational risks, reduce those career risks. Because what AI does is actually, just as we use AI to convert English to Spanish or whatever, it can convert COBOL to full stack Java, right? Much faster. So it has compressed that time. Now, the interesting thing is the conversion of COBOL to full Java the translation can happen. It used to happen even 15 years ago with technology. The difference is that AI can also take into account semantic aspects. In the past, you could only do syntactic translation. Now you can look at the context, understand what a particular variable means, see its usage, and pop it. Now, in this translation, I think there are two flavors of AI. Stochastic, which is Gen AI, which means it predicts the probability of the next word.
Sure.
And then there is deterministic, which is you actually have machine learning models.
More classical AI.
Yeah. I personally think that both versions, we talk a lot about Gen AI, but the thing is, both of these types of AI are very relevant to reducing the barriers to knowledge and reducing the operational risk that allows you to move from old tech to new tech. And I think personally, that's one of the largest target addressable markets for people like me. For all the talk about AI transforming our world, in the commercial world, I still see hesitant mini steps of POCs. AI is still a feature on a product that already exists. Most of the people who come to us for building new products, they say, I want to have this AI-enabled feature. I want to spend $250,000 on it, but that's it. Nobody is rewriting their software platforms in a completely new way, right?
And that's the opportunity.
That's the opportunity, but a long-term one. It's not going to help me hit my
quarterly targets.
Full year 2025 goals, right? And then there is hey, can you do it cheaper and faster for me? Which actually, for the large incumbents, it actually is a compression of their core revenue. For mid-size attackers like me, it's an opportunity. Yes.
Got it.
But the real new market that's opening up, which is not the first or the second, is the one in the middle. It's translating legacy tech debt into new code. That's a whole new market that's growing, and that's where we are playing a lot.
Absolutely. So if you're a board of, be a board member of a large company, which is tech-enabled company or a tech company, or a CEO, what should be the question they should be asking the CTO and the product teams on how they measure software in the context of all the things changing in AI? What should they ask them? Very sharp, specific questions.
It's a good question, because I'm trying to give you the answer that I actually see in the battlefield. See, I think most technology experts and leaders are quite smart and competent around the measurement question. The question one should ask is, they know this, why aren't they doing it?
Okay.
Yeah. And the problem is the same as what I did in my research 25 years ago. The problem is not the measurement, it's the people. Okay. So I'll give you an example. I was in a workshop where the CFO of this company said, well, I think this platform that Ranjit is talking about, we should use it. I would like to see the measurement every day. And I said to him, listen, not every day. You can see it real time. I can pull the numbers up on your dashboard. You can see it anytime. And I could see a deathly silence go through that workshop. Which software team wants their CFO to see their productivity real time every day?
Okay.
Okay. So that's probably the first one. Nobody likes to be measured. I don't like to be measured, although I talk about it, right?
Yeah.
But it's a fact of life. Nobody, freely says measure me. You have to figure out a way for them to get the incentive out of it.
We are carrying trauma from our school days.
Yes, exactly, right? So that's the first thing. So why are you not measuring? Second is, AI actually improves productivity. But we have built an entire generation of technology leaders who focus on cost and who talk productivity, but actually have, because of the first barrier, have never really looked at productivity.
Sure.
Or have not been held, even in their governance process, when the annual budgeting cycle happens, they are not held accountable for productivity really.
Okay.
They are saying, well, this time it's a current earnings problems, cut your costs, or hey, this time we want a new product, spend more.
Sure.
It's a cost-driven thing.
Interesting.
And so the second problem is governance. For you to truly make a shift from cost to productivity, the outcomes of the software have to be clearly articulated, defined. And this doesn't mean business outcomes every time. Those may be harder. But you could say you need to be able to do all your sprints at 95% completion rate and reduce your costs or increase your costs. I think there is a productivity metric that's just not standard in most governance, so it's not relevant. So why should they measure it? So that's the second one. And I think the third one is, this pertains to my industry and my interface with technology spenders. At least in outsourcing, that cost paradigm has gone to the next level. Most procurement departments, when they outsource, they want rate cards. I can tell them the big story about AI productivity. They hear you out and then say, okay, can you send me your rate card?
Yeah.
Well, that's not a productivity discussion.
Sure.
By the same time, the middle manager in IT also is used to talking to his vendors or her vendors like that. So there's also a way of how you source business, and you get work done.
Yeah.
All these three factors.
So what you're saying is the complexity of the organizational behavior and change seems to be a much larger barrier than adopting code generation in the company.
Technology is easy. People are the challenge.
So when companies come to Ness and say, hey, I'm really committed to doing this, how would you help them? What is your approach?
There are 2 or 3 scenarios. One is where they don't know us. That's a very different scenario where I've worked with them to build out their product for the last 10 years.
Sure.
The second one is easier than the first.
Okay.
In the second one, literally today, we have a German automotive company, all the German cars, they have these mapping navigation solutions. We build those for one of the software providers. And we went to them and said, we've been doing this with you for 10 years, right? So why don't we take this product, okay, and we will define a set of outcomes for you. We call it product sustenance. And we will guarantee you these outputs. We will take this work on, and we will use AI, automation, process, whatever are the levers to improve the productivity. And literally on day one, I will give you the benefits of productivity, although I have not received it. The only thing I would ask for is give me a 3 or 4 year contract so I have time to improve my productivity. I think this is a new way to do business, and AI can be a big accelerator of that. I think for existing customers, that's what I go to market with.
Interesting. And the point, coming back to the point on change management, behavior becoming harder, but it also could create opportunities for you to go after larger opportunity, because you can take over that team and transform the team rather than you being purely a tools provider, people provider. And you take the team and transform, you provide an outcome to the client.
Absolutely.
So it creates opportunity for you to get the larger deals.
Absolutely. I mean, I think that's but to do that, you need to have a progressive client and a client in the right state of their economic journey. To be able to do that. And so we are seeing that more and more. And I do think it'll become standard over the next 5 years. We are just seeing the trickle. At some point, remember when we started outsourcing, I remember this, the Indian IT outsourcing industry, NASSCOM, which is the industry, I was working with them, and they said, well, I think this industry has a lot of potential. I think by 2010, it's going to be $2 billion. And somebody in the room said, $2 billion is nothing. It's going to be at least $50 billion. And they looked at what was happening then, and they said, well, I'm barely hitting 500. So I think it's the same with this situation. It'll happen to us much faster than we think. We are in the initial stages. Eventually, the commercial machine will start playing its role.
I think as an industry observer and a student of tech services, right, we see this as a massive opportunity for companies like Ness because you have, I would say, three types of customers. One are these large leaders in their area, maybe JP Morgan and companies like that. They would figure out how to do this. And there are these cutting edge AI native VC funded Silicon Valley and New York based companies. They will figure out how to do it. In between, there is a vast number of companies, right? And those companies, exactly the reasons you mentioned, will find it very difficult to transform. And that's an opportunity for a nimble company like,
Absolutely agree with you. I think it's the mid-market where they may not have the technology maturity. And in the mid-market, I would say there are sub-segments that are particularly ripe, like private equity portfolio companies. I think you'll find that they have a very urgent value creation agenda.
Correct.
And that also drives a change in behavior.
And there's a significant top-down change or behavior change they could drive.
Correct.
Thanks a lot, Ranjit, and Dr. Ranjit, as you say.
That's all right.
I see Dr. Ranjit everywhere. Now, thanks a lot, Ranjit, for the time. It was great to discuss with you on what's happening in overall in AI-led software development, more specifically around metrics, and how the tech services industry is changing and the opportunity for a company like you. Thanks for your time.
My pleasure. Thank you.
Thank you, everyone. Thanks for joining the podcast. Till the next one, this is your host, Pari Natarajan. Bye.
Thank you for listening to this episode of the Business Resilience Series. Stay tuned for more such interesting episodes. You can listen to our podcast on Apple Podcast, Google Podcast, Spotify, or wherever you get your podcast from. To know more about Zinnov, visit our website, www.zinnov.com, or drop us a note at info@zinnov.com. Follow us on Twitter @Zinnov for regular updates on our content. Thank you again for listening to the Business Resilience Series of the Zinnov Podcast.